How's it going, everybody? I'd like to welcome you to our next mini section inside of IKEv1, where we're going to first start taking a look at why you would need to encrypt things like GRE tunnels. So it's one thing to hear, and I've heard many instructors, that's how I learned about it, was just being told it was a bad idea, so I just took the person at their word. They were right, but I wanted to provide a little bit of actual uh, clarity and transparency to the idea. So what what I'm going to do is on CSR3, I'm going to go and I'm going to configure it to send to appear with something like CSR5, for example. And CSR5 is we're going to appear between these two devices, and we're going to send traffic over the GRE tunnel and see exactly how that comes into play. I have actually got a Wireshark setup going here. So if I was to do something like go on CSR3 and let's ping 51.0.0.5, we should see pings going back and forth. We can see it's ICMP, all that type of stuff. So we know that's not that to be true. So let's go ahead and set up a GRE tunnel between these two devices. So we're going to go to global config. We're going to type an interface tunnel, and we're just going to say this will be 35. We'll type an IP address is going to be 10.3.5.3/24. We'll type tunnel source is going to be gig1. The tunnel destination will be 51.0.0.5, and that's pretty much all we need to do. The tunnel is up now. We go over to CSR5. We type in interface tunnel 35. The tunnel source is gig1. The tunnel destination is going to be 31.0.0.3. And the IP address on this guy is going to be 10.3.5.5/24. Pretty standard setup, right? Now, if we look at the Wireshark, we should start to see communication going back and forth between these guys. Eventually, hopefully, maybe. So let's go ahead and do another ping from CSR3. But this time we're going to we should be able to ping 10.3.5.5 and see what happens. So the ping goes across. If we look at the addressing, we're now going to see that GRE is now the encapsulation. We can see all that type of stuff coming into play and stuff like that. One of the things we're going to do is I'm going to add in some minor little details. For example, on this configuration, I'm going to go back to global config and interface tunnel 35. I'm going to shut the tunnel down, and I'm going to say that the tunnel key is 35. And go up to 5. We're going to shut it. We'll just type it in. Tunnel key is 35. We'll go back over to CSR3. We will no shut the interface, bring that guy back online. And so what I'll do is I'll come down here a little bit further. Let me scoot this up just a little bit so it's not so hard to see. Bring this down to here, bring it all the way down. And then I'm just going to do another ping. So the ping should go across. And inside the GRE header, there's a tunnel bit key is now turned on. Well, I wanted to show you guys the difference between the two. If we scroll up a little bit to the first set of pings, the tunnel key bit was turned off. And if we come down here a little bit further, we can see the tunnel key bit is turned on. By turning the tunnel key command on, it goes in there. There's some other ones in here that you can throw in. Interface tunnel 35, the tunnel, you can do you can be more specific if you'd like. Trying to find out what there's a checksum value. So you can type end-to-end checksumming of packets. If we were to do that, you would see this, the checksum bit would be turned on and things like that. These are just specific features you can turn on. Think of the tunnel key like you would a ISACAMP password, to where if they don't match up, you're not going to allow the communication back and forth. So think of things like that. I wanted just to show you how that comes into play in terms of its operations, because I feel like that's a really big deal. If you are going to be dealing with these technologies, you should understand why you should encrypt them. So this is just a data plane capture, right? I'm able to see the data clear as day. So that's why when I talk about stuff, I want to be able to provide a actual practical implementation of how that would come into play. So now, since we're pretty early in our setup, the next thing that I want to do is I want to go ahead and between CSR3 and CSR5, I want to set up a site-to-site GRE tunnel using a crypto map config. So I'm going to use a very similar stanza to this guy right here. And the difference between the two is I'm going to be using it as transport. Now, you might ask, why transport versus tunnel? The tunnel technique is used to basically, let me go ahead and pull up my Ink2Go setup because I want to just draw this out. It'll be a lot easier to understand if I just draw it out. So let's go ahead and take a look at it from this perspective. If we come in here and we draw a line, if you do the line, go from, let's say, CSR2 to CSR4, for example, and you do, actually, let me back this up. Let's do it from here to inside interface to inside interface. Let me choose a different color. Let me go to red, so it's easier for you guys to see. So we go red from inside interface. One of these days I'll get it in the right place. Inside interface to inside interface, like this. This is your actual tunnel. Let me switch over to an ellipse, which will allow me to draw a circle. There we go, and then like that. The idea is anything that goes inside of the tunnel between these two endpoints, I'll just draw some arrows and I'll make them green, for example. Any traffic that comes in over the tunnel like this or goes out over the tunnel like that, that's actually what's being encrypted, right? It's data plane communication, so gig 2 to gig 2 on the VPN endpoint devices. The traffic is being sent over in a tunnel. It's not, there's no IP addressing information here. There's no additional headers that are being sent. The ESP header is sitting behind the IP header of the outside header, which is the public IP, so that it knows what VPN endpoint to talk to, right? That information is being exposed because the global routing table that is the internet or the MPLS backbone needs to know what particular VPN endpoint do I need to send this traffic towards. Once the traffic gets there, the rest of it's ESP, so it needs to be decrypted. That's what's happening with all of this communication here. When we say tunnel, I want you to visualize in your head an actual tunnel set up between these two devices that's allowing the traffic just to pass through it as long as it matches on the crypto ACL. Where transport is a little bit different. Transport is doing it from the perspective of, let's do a line, from the device is terminating the tunnel itself and going from there. So it's a little bit of a different type of scenario. So if we draw a line from, actually let's make this red so it's easier for you guys to see. It's going from here to here, but notice that I'm on the device itself. I'm not passing through the device, and we'll go to here. So it's terminating on the device, right? And notice how I've got it on the outside interface, not the inside interface. Now if I draw this down as an ellipse to make our tunnel endpoint here a circle, and this one a circle, like so, and I go back to an arrow, and I go back to yellow-green, we have traffic coming in, like, let me make that go all the way through. Actually, data is actually terminating on the router itself. So this is where your GRE or your EIGRP, your OSPF, your BGP peerings are able to form over a GRE tunnel, and they're able to terminate. And then the routing processes that are sitting behind here. So, for example, we have EIGRP adjacency set up between CSR4 and CSR8, and then CSR2 and CSR7, they're extending information. So what ends up happening is any of these prefixes right here are able to be sent across the wire to here. So that's why we see traffic going across the wire like so, back and forth like that. So the green arrows indicate data plane traffic. The red lines indicate control plane. So we have all this data going back and forth. The only encrypted part of it is when you do move over to GRE over IPsec, whether you're using a crypto profile or a crypto map, it doesn't make much of a difference. I prefer doing it with a crypto profile. And the reason why I prefer that, but I'll show you the crypto map. That's why I'm going through this explanation. When we're dealing with the crypto map design, we have to understand that we're no longer going to be using a crypto map and an access list to match on the data plane traffic. What we're going to do is we're going to do something on the router to point traffic to a particular destination, whether it's policy-based routing, whether it's a static route, whether it's dynamic routing, whatever your mechanism you use in order to send traffic over the GRE tunnel, it needs to be pointed to that. So instead of sending a default route out towards the internet and then it just happens to fall into play when you do a routing table lookup, you move the traffic to the outside interface, the outside interface looks at the crypto ACL and goes, oh, well, you're not being natted. You're going to go ahead and be encrypted and sent over these ESPSAs that are sent and received between me and somebody else. Well, when you go to a GRE tunnel, now you're adding routing into the routing table. So you're no longer having to move to the outside interface. Now you're saying, instead of moving it to the outside interface, I want you to route it towards a tunnel. The tunnel is tied to the outside interface. This is the point where you move from unicast only communication, where no routing protocols are supported. That's not 100% true, but for the sake of argument, I'm just going to say it. There are some unique scenarios where that wouldn't be the case, outside of the scope of my discussion right now. But this is where you'd be able to turn dynamic routing on, and you'd be able to take that additional path. The crypto ACL is still used, right? The ACL that we have highlighted right here. Oh, I'm not back over here to this. This right here is still leveraged, but we're not matching on the source and destination of the traffic. We're going to match on the VPN endpoints. So we're going to say permit GRE any. So if GRE is in the routing table and it's the next hop to a particular destination, we can go ahead and allow that traffic to go out. So that's actually what we're going to go do now. I wanted to draw this out so you guys would be able to see this. What we're going to do is a crypto ACL. I'm going to go and create a new one. And what I'm going to do is I'm going to say this guy here is going to be 51.0.0.5. And the crypto ACL that I'm going to be using is IP access list extended. And the name of it is going to be GRE over VPN. And I'm going to type in permit GRE any. So all I need to do is match on GRE. And then I get to go take this particular information right here, paste it right there. And then I'm going to come in here and I'm going to say the peer is going to be 51.0.0.5. That's going to be my configuration. And then I get to come over here onto CSR3 and I get to dump this config onto there, like so. I go to CSR3 and I dump this config in like so. ISACamp is now turned on. I bring it back up, and I just change the remote endpoint. I say 31.0.0.3, 31.0.0.3, and then I just have to create another entry in the crypto map. So I will say this will be crypto map entry 20, something along those lines. I do that. I don't even need to place it on the interface because it's already there. And I just come in here and I take this information like so. I go over to CSR5, show run section crypto. The crypto map entry is all I need. So actually, let me just go and grab that right there. I need to grab the this information right here and right there. That's all I need. I go back to CSR5, go to global config, copy and paste. I do show run section crypto, and that's it. Now, because of the fact that I'm matching on that communication now, once I go and do a show crypto ISA SA, what it should end up happening is when I start to send ping traffic across the wire, if we do a show IP route, we're going to now have a tunnel in here, right? So if I ping 10.3.5.5, the ping does work. If we do a show crypto ISA SA, you'll notice that I have a connection now to it. If I do a show crypto IPsec SA, we notice we have 4 pings, but you'll notice that it doesn't matter what it is that I match on inside of the address or the mask. It's all zeros. But in the protocol section, it's 47 now. If I go over to CSR5 and I hit the up arrow, guess what? Now I have a connection to CSR3. And if I do a show crypto IPsec essay, I have 47 as my connection right here, which is what I would expect to see. So now, the question is, okay, how do I send traffic over the tunnel? I mean, that's actually a really easy answer. All I have to do now is I have to send, when traffic is coming back to CSR5, instead of sending it over the crypto map that's set up to CSR2, I come in here and I say one of 3 things. Show IP route. I can either send the traffic out the default gateway, which is this guy right here, or I can say IP route to 10.1.0.0 /16, send it out tunnel 35. That's one way I can do that. Let's go over to CSR3 and do the exact same thing. We're going to say show IP route. I'm going to go to global config, and I'm going to type in IP route to 172.25.0.0 /16 out tunnel 35. Now do show IP route. We should be able to send the traffic out towards that particular destination. Now, what I have to do, and this is where it gets a little bit more interesting on the hub side, so CSR3 side. The reason why it gets more interesting now is because CSR7 is going to be looking at this from the perspective of, let's go look at CSR7. If we look at the show IP route, we're going to see that we should be sending traffic towards CSR2. Now, one of the things that I can do is I can do a more specific leaking. So this means on CSR3, I get to get a little bit unique with my configuration. So I'm going to type an IP prefix list. And this is where routing comes in before cryptography comes in. The prefix list name is going to be prefix list for VPN. And I'm going to type in the permit is going to be 172.25.0.0 /16. And I'm going to hit the enter key. And I'm going to type in the summary address. So interface gig 2, I'm going to type in summary. I'm running EIGRP globally. So router EIGRP VPN, address family IPv4, autonomous system 100, AF interface gig 2, and summary address is going to be an all zeros route, right? But I'm also going to say a leak map. The leak map name is going to be, and I might have to tie this to a route map. I'll have to double check. We'll say PLVPN and do that. So now we're going to have a resynchronization. I go back to CSR7. I hit the up arrow. And now, yeah, I might have to tie that to a route map. So not that big of a deal. Let me just go do that real quick. On CSR3, I create a route map. So route-map called PLVPN. Say match IP address and prefix list PLVPN. And now I should be okay with that setup. So now if I go back to CSR7, I should be receiving a, oh there, okay, resynchronized. And the idea would be to see a 172.25 prefix come through. Let me just make sure it's being matched on the CSR3 side. Show IP prefix list. Detail. So it's, okay, so it doesn't exist in the routing table yet. So what I will do is, normally I would do, you can do policy-based routing. What I will do on CSR7 is I will cheat a little bit. IP route to 172.25.0.0 /16. I'm going to point to 172.16.1.3. So I'll just create a static route, and we'll have that will point towards CSR3 in this particular case. and we should be good to go at that point. So I'm going to go ahead and I'm going to attempt to ping 172.25.0.8, sourcing from loopback 0, and the ping does work. If we look at CSR3 and we look at the show crypto IPsec SA, we have 9 pings. So that's exactly what I'm expecting to see. So now if we go back to CSR7 and I do a trace route, you'll notice that prior to this, I haven't done any trace routes. You might wonder why. Well, the main reason why I haven't done a trace route is because I haven't had an interface traversing the internet between CSR2 and any of the remote side devices. Now I have a connection between CSR3 and CSR5. So if we go back to the line and I draw this in red, now I have this connection from CSR3 to CSR5 going back and forth. And let me draw the ellipse real quick just so you guys can see this all drawn out. Now we have this set up like that and like this. And now we should have communication happening between these devices over GRE tunnels. But we're just doing static routing, right? We have this communication going back and forth that's going to allow the traffic between these devices to work the way that we need it to. So now CSR3 the traffic should be going that way. We know that to be true because we just did the test and it does work. So now if I go back over here to CSR7 and I do a trace route to 172.25.0.8, sourcing from loopback 0 numerically, the path that I take is going to router 3, and then it jumps over the GRE tunnel. Now if I jump back over here to Wireshark and I come down here at the bottom, before now we have the ARP and all that type of stuff, then we have identity protection, we can see the communication going back and forth, and now we have ESP packets. So the traffic is being encrypted the way that we are claiming it to be encrypted. So that's why when I wanted to show you this is how that comes into play. Now we've talked about crypto maps and stuff like that, so that's pretty straightforward stuff. In the next video, we're going to take a look at dealing with a crypto profile, which is a different type of scenario altogether, and this becomes a little bit more interesting, and this is where I'm going to start tying we're going to have to get away from the default transform set and start creating our own, because it gets a little kludgy when you are still using the default crypto transfer, or the crypto IPsec transform set. So if you have any questions, leave me a comment in the comment section below. Until next time, guys, take it easy.